All right, now let's graph the second one. I don't know if you can see that was a cube. So f of x equals negative x plus 2 cubed. The graph is really big with the x minus 4, so I've changed that to an x minus 1, just to keep it on the piece of paper. All right, so first let's find our x-intercepts. We only have 2. It's factored, so set your factors equal to 0. X plus 2 equals 0, so x is negative 2. Oh, I should probably label this as x-intercepts. And then x minus 1 is 0, x equals 1. So there we go. We can. I'm going to wait to graph it to see if I have to change the scale at all. Our y-intercept. So just plug in 0 for x. F of 0 equals negative 0 plus 2 cubed times 0 minus 1. So that's going to be negative 2 cubed times negative 1. That's going to be a positive 8. When it was a 4, it was much, much larger. Did not fit on the graph at all. All right, so we've got our x-intercept, y-intercept. We need our table. All right, and so we need to look on either side of our x-intercepts. Is the function above the x-axis or below, and then between our x-intercepts. So we need for our smallest x-intercept is negative 2, so we need for x less than negative 2. We need to know what happens between negative 2 and 1, between the two x-intercepts, and we need to know what happens after 1. All right, and we're just going to plug it in and see what we get. Easy peasy. All right, so f of so something less than negative 2 would be negative 3. Keep forgetting that negative there. Negative 3 plus 2 cubed times negative 3 minus 1. All right, so that's going to be a negative 1 cubed times negative 4. So we're going to end up with 3 negatives there. So negative 1 times negative 1 times negative 4 is going to be negative 4. So negative. So by the way, this is a quartic, all right? So both ends are going to go the same direction. And we got that one going as negative. All right, so we already know this is positive because we've plugged in a value in between those two x-intercepts, and that was our y-intercept. Let's see if that value is more extreme than another integer I could plug in, which is negative 1. Let's just see what we get for negative 1. So negative 1 plus 2 cubed and negative 1 minus 1. I don't think it's going to be more extreme, but because that's just going to be 1 cubed times negative 2. Oops, don't forget our little negative out there. So that's going to end up being a positive 2. So not very extreme. So this is our relative max. Oh, excuse me, I thought I was going to sneeze. That is our only extreme value, right? Because we have two x-intercepts, there'll be one turning point between them. Because after all, once you leave the x-axis, you got to get back somehow. And then we need to plug in what happens after 1. None of these are an even multiplicity, so I'm expecting to cross at every x-intercept. But let's double check and plug in something greater than 1, and that'll be 2. F of 2 equals negative 2 plus 2 cubed times 2 minus 1. So that's negative 4 cubed, oh my, times 1. It'll be negative. It'll be negative 64. No chance for graphing that one. But at least it wasn't a turning point, and it's not an intercept, and so it won't really affect us. All right, so now let's graph our points. All right, so we have our x-intercepts, negative 2, 0, and 1, 0. Our y-intercept, which is also going to be our turning point, 1, 2, 3, 4, 5, 6, 7, 8. This is approximately where we would turn around. Right? I'm not going to worry if it's a smidge more or a smidge less. Right? It's between our x-intercepts, and it's the integer that has the most extreme value. And then we have to think about what our graph is going to do, right? So for x values, and we could graph f of negative 3 too. It was just a value we plugged in. to see what our graph was doing for our sine chart. This is our sine chart. All right, and so we know it's going to be negative on either side of the x-intercepts and positive between. All right, so our graph is going to cross. It kind of flattens out a little bit, but as long as you're making it cross, it's fine. And then turn for the maximum, and then cross. So, because we have that repeated 3 times x-intercept, we don't look so M-y or W-y, but that would be a quartic function, right? That's got one of our roots is repeated 3 times, and then we have one other distinct root. And so now we can just analyze. We can look at where our function is greater than 0 and less than 0. So our function is greater than 0 just between the x-intercepts. So just between -2 and 1. Everywhere else, our function is going to be negative. Right? So it's positive. I'll actually write that in. I think I have enough space. So it's positive where we're above the x-axis, and it's negative where we're below the x-axis. So f of x is less than 0 from -infinity to -2, and from from 1 to infinity. And notice that takes up the entire domain, right, which we didn't do. -infinity to infinity because it's polynomial. The range is restricted because we turn around. -infinity to 8. You could put a bracket there because we go through 8. It's our approximate range. Based on our graph, it's our range. All right, so we've got where we're increasing, where we're decreasing. We've got where we're positive and where we're negative. Now let's do where we're increasing, where we're decreasing, just to highlight the differences between them. So positive just means you're above the x-axis. Negative means you're below. Increasing means your x values are getting larger. Right? So positive and negative switch at the x-intercepts. Right? They switch right here. Increasing, decreasing, switch at the turning points. All right, so we're increasing from -infinity to 0, and then we're decreasing. Ooh, well, that was not meant to happen. I must have leaned on the board. We're decreasing from 0 to infinity. Right? So you can be increasing and negative. Right? So here it's increasing and negative. It's increasing because the y values are getting larger as we look left to right. It's negative because it's below the x-axis. Right? And you can be decreasing but positive. So here the graph is decreasing but positive. Right? Our y values are getting smaller and where we're above the x-axis. So it's decreasing where I just outlined in red. It's increasing where I outlined in green. Right? Not to be confused with being above the x-axis and below. The last thing we're going to do on this one, if we can find some space, is the end behavior. All right, I guess we'll squeeze that in just right over here. So f of x, so both ends go down. It approaches -infinity as x approaches -infinity, and the function approaches -infinity as x approaches infinity. So no matter what x does, our function is going down to -infinity. It's just dragging his little hands. All right, that's the end of this graph. We'll do one more on the next video. Thanks for watching. Bye for now.